Now let us discuss some questions in mathematical reasoning. Now the question says, the logical statement P implies Q and Q implies not P is equivalent to which of the following options? So the statement given is P implies Q and Q implies not P. Now we know that A implies B is equivalent to not A or B. So I can write P implies Q as not P or Q, and I can write Q implies not P as not Q or not P. Now we also know that A or B is same as B or A. So I can write it as not P or Q and not P or not Q. Now this is distributive law. So I can write it as not P or Q and not Q. Now we know that Q and not Q is simply false. So I'll get it as not P or false, and not P or false is simply not P. So the statement is equivalent to not P, which is option number A. Let A, B, C and D be four non-empty sets. We need to find contrapositive statement of if A is a subset of B and B is a subset of D, then A is a subset of C. So let us say this is P, this is Q, and this is R. So we are given that P and Q implies R. Now what is contrapositive of if A then B? It is if not B then not A. So in this case contrapositive will be not R implies not P and Q, and we know that De Morgan's law says this is not P or not Q. So what is R? R is A is a subset of C. Now not R is if A is not a subset of, then A is not a subset of B or B is not a subset of D. So which is option number A. Now the question again is, which of the following statement is a tautology? Now we know that A implies B is not A or B. So the option which is more likely to be a tautology is option number D, because I see disjunction there. So I'll try it with option number D. So which is not of P or not Q implies P or Q. Now A implies B is not A or B. So I write not of not P or not Q or P or Q. Now not of not A is simply A. So this is P or not Q or P or Q. So I can write it as P or not Q or Q, and not Q or Q is simply true. So this is P or true, and which is simply true. So option number D itself is a tautology. Now question number 15 is, we need to find negation of this statement, and the statement is root 5 is an integer or 5 is an irrational. So we need to find negation of this statement. Suppose this statement is A and this is B. So we need to find negation of A or B. Now we know that negation of A or B is negation of A and negation of B, which is De Morgan's law. So answer to this question will be not A. Not A is root 5 is not an integer and 5 is not irrational, which is option number D. Now the question is, if P implies P and not Q is false, then we need to find truth values of P and Q. So we can always solve these questions using truth table, but here we'll do it with algebra. So statement is P implies P and not Q. So again, A implies B is not A or B. Now I'll use distributive law. So this is not P or P and not P or not Q. Now not P or P is simply true. So this is true and not P or not Q. Now true and A is simply A. So this is not P or not Q, and De Morgan's law says, so this is not P and Q. So now it says this not P and Q, this is false. So this is false when P and Q is true. And we know that conjunction is true only when both P and Q, they are true. So which is option number D. Now the question is, we need to find contrapositive of this statement. If you are born in India, then you are a citizen of India. So that is, we are given that A implies B, and we know that contrapositive of this statement will be not B implies not A. So which is, if you are not a citizen of India, then you are not born in India. So which is option number A. Now question number 7 says, which of the following statement is not a tautology? So we'll start with statement A, which is P and Q implies not P or Q. So A implies B is not A. So this is not of P and Q or not P or Q. So I can write it as not P or not Q or not P or Q. So I can write it as not P or not P or not Q or Q. So not P or P is simply not P, or Q or not Q is simply true, and A or true is simply true. So option number A, it's a tautology. Now second one is P and Q implies P. So it simply means not of P and Q or P, which is not P or not Q or P. Now disjunction is associative and commutative. So I can write not P or P or not Q. Not P or P is simply true. So this is true or not Q, and true or not Q is simply true. So this is also a tautology. Now the third option is P implies P or Q. So which is equivalent to not P or Q. Now not P or P is true, true or Q is simply true. So option number C is also tautology. So that means the option which is not a tautology is option number D, and we'll prove it also. So this is P or Q implies P or not Q. So I can write it as not of P or Q or P or not Q. So I'll write it as not P and not Q or P or not Q. So if I'll use distributive law, I can write not P or not Q and not Q or P or not Q. Now not P or P is simply true, and true or not Q is simply true again. So this is true and this is now not Q or not Q, which is not Q. So this is not Q or P, and we know that true and A is simply A. So this is not Q or P. So this statement is equivalent to not Q or P, and which is not a tautology. Now question number 22 says we need to find negation of this expression, which is P or not P and Q. So we'll need to find negation of this. First we'll simplify this. So we'll use distributive law. So this is not of, and this is P or not P and P or Q. Now P or not P is simply true, and true and A is simply A. So this is not of P or Q, and not of P or Q is not P and not Q by De Morgan's law, which is option number A. Now the question is, if P implies Q or R is false, then we need to find truth values of P, Q and R. Now we know that A implies B is not A or B. So this is not P or Q or R. Now this statement, it is false. Now since we have disjunction here, so disjunction of A, B, C will always be false when each of this, not P, Q and R, they are false, which simply means P must be true, Q must be false and R must be false. So it should be true, false, false, and that's option number B. Now the question is, we need to find negation of this Boolean expression, which is not S or not R and S. So we'll need to find negation of this statement. Now first we'll simplify this. We'll use distributive law. So we'll write not of. So this is not S or not R and this is not S or S. Now not S or S, it is simply true, and A and true is simply A. So this is not of not S or not R. Now not of not S is simply S and then De Morgan's law, and this is R. So it is equivalent to S intersection R, which is option number A. Another question is, if the truth value of the statement P implies not Q or R is false, then we need to find truth values of P, Q and R. So again, this is not P or not Q or R. Now we know that it is or disjunction. So it can only be false when each of not P, not Q and R, they are false. So that means P should be true, Q should be true and R should be false, which is true, true and false. Now here the question is, not P of, P implies not Q is equivalent to which of the following expressions? So it is not of, P implies not of Q, and A implies B is not A or B. So we can write it as, so this is not and then De Morgan's law and this is Q. So it is equivalent to P and Q, which is option number A. Now here the question says this expression P and this symbol Q and not P dot Q is equivalent to P and Q, where this plus and dot, they belong to this set of conjunction and disjunction. Then we need to find this ordered pair. So we'll start with option number A, and option number A is P and Q and not P or Q. So what we'll do is we'll use distributive property. So we'll write P and Q and not P or P and Q and Q. Now conjunction, it is commutative and associative, so I can write Pn not P and Q union, and here I can write Pn and this is Q and Q. Now P and not P is simply false, and false and Q is simply false. So this is false, or and Q and Q is simply Q. It is P and Q. Now false or A is simply A. So this is equivalent to P and Q. So our first option itself is equivalent to P and Q. So basically this is option number A. So here we need to find out this logical statement is equivalent to which of the following options. So I'm given that. So this is not of not P or Q or P and R, and this is not Q and R. Now first we'll simplify this. I can write this as P and not Q or P and R, and this is not Q and R. Now we can write it as distributive law. So I can write it as P and not Q or R and not Q and R. Now since conjunction is associative, I can write it as Pn and this is not Q or R and this is not Q and R. Now I'll use distributive law, but then I want to distribute this end. So what I'll do is I'll use commutative property first. So I'll write, so this is Pn and this is not Q and R and this is not Q or R. So now I can distribute it as, so this is Pn and this is not Q and R and not Q or not Q and R. So this is Pn not Q and not Q is simply not Q. So this is not Q and R. This is union, and this is R and R, which is simply R. So this is again not Q and R. Now A or A is simply A. So this is P and not Q and R. Now again we know that conjunction is associative and commutative. So I'll write P and R and not Q, which is your option number C. Now question number 41 says, let P be the statement. Now here the question is, let P be the statement X is an irrational number and Q is the statement Y is a transcendental number, and R be the statement that X is rational if and only if Y is transcendental. So that means this R, it is equivalent to X is rational. So X is rational means, so this is not P if and only if Y is transcendental, which is Q. So basically R is not P if and only if Q. Now statement 1 says R is equivalent to either Q or P. Now this is exclusive OR. So that is only one of them can be true. So it will be Q and not P, or not Q and P. And statement 2 is R is equivalent to not of P if and only if not of Q. So now we'll solve this question using truth table. So for biconditional statement, it is always better to use truth table rather than using algebraic properties, because then the statement will be very long and it will be very difficult to sort it out. So here I'll write truth values for P, Q, not P, not Q, not P, biconditional Q, Q and not P, not Q and P, and then Q and not P, or not Q and P, and then P biconditional of not Q, and finally biconditional of not of P if and only if not Q. So truth values are true, 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 false, false, true, and false, false. Now not P will be false, false, true, true, and not Q is false, true, false and true. Now not P if and only if Q. So not P if and only if Q. So it will be only true when either both of them are true or both of them are false. So that means it will be true only when both of them they are false or both of them they are true. In all of the cases it will be simply false. Now we'll find Q and not P. Q and not P will be true only when both of them they are true. So it will be true, and all the cases it will be simply false. And not Q and P. So for not Q and P, it is true only when both of them they are true. So this is true, and then it is false. So now if I'll take disjunction of these two statements, so then false and false, it is false. False, true, 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 false, true, and false, false is simply false. Now, what is P if and only if not Q? P if and only if not Q. So true, false, false, true, 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 false, false, true, false, true, false. And if I take negation of that, I'll get true, false, false, and true. Now, what's R? R is not P if and only if Q. So that's your R. Now, what's R in statement 1? In statement 1, that's the value of R. So this is R for statement 1, and this is R for statement 2. Now, if we look at truth values, then these two values, they are same, and this value it is different. So that means statement 1 is right and statement 2 is wrong. So answer to this question is option number D. Now question number 42 is this statement, which is P implies Q implies P is equivalent to not P or Q implies P, and this is not P or, and this is not Q or P. Now disjunction, it is associative and commutative. So I'll write not P or P or not Q. Now not P or P is simply true, and true or A is simply true. So this is a tautology. Now, out of these four statements, which one is likely to be a tautology? So I know that it'll be not P or P. So I think it should be tautology. So I'll look at option number B, which is P implies P or Q. So which is equivalent to not P or Q, and not P or P is simply true, and true or Q is simply true. So again, it is a tautology. So that means this statement is equivalent to option number B. Now question number 47 is, let S be a non-empty subset of R, and there is a statement P which is, there is a rational number X belongs to S such that X is greater than 0, and we need to find negation of statement P. Now we know that negation of there exists is for all or every. So there is a rational number, so its negation should be every rational number X belongs to S. Now here the condition is X is greater than 0, so negation should be X should be less than or equal to 0. So negation of this statement should be every rational number X belongs to S should be X is less than or equal to 0, and that's your option number B. There are three statements. P is Suman is brilliant, Q is Suman is rich, and R is Suman is honest. So we need to find negation of the statement. Suman is brilliant. Suman is brilliant is P and dishonest. So this is P and not R if and only if. So that is if and only if Suman is rich, which is Q, and we need to find negation of this statement. So we know that A if and only if B is equivalent to B if and only if A. So I can also write it as, so this is Q if and only if P and not R, and that's your option number A. Now question number 61 says, this statement is equivalent to which of the following? So which is not of P if and only if not Q. Now for if and only if, it's always better to go with truth table method. So I'll take P, Q, not Q, then P, biconditional not Q, and then not of P, biconditional not Q. So this is true, 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 false, false, true, false, false. This is false, true, false, and true. Now P biconditional not Q, so true, false, false, true, 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 false, false, true, false, true, false. Negation is true, false, false, and true. Now basically it's not a tautology, and it is not a contradiction, basically not a fallacy. Now is it equivalent to P if and only if Q? So P if and only if Q will be, so true, true is true, true, false is false, false, true is false, false, false is true. In this case, both the truth values or both the table entries, they're same. So that means it is equivalent to P if and only if Q. Question number 63 says, we need to find negation of this, which is not S or not R and S, and we need to find negation of this. First we'll use distributive law. So this is not of, so this is not S or not R, and this is not S or S. Now not S or S, it is simply true, and A and true is simply A. So this is not of, so this is not S or not R. So this is S and then De Morgan's law, and this is R. So it is equivalent to S intersection R, which is option number B. Now here statement 1 is Pn not Q and not P and Q is a fallacy. So we know that conjunction is associative and commutative. So I can write it as P and not P and not Q and Q. So P and not P, it is false, and Q and not Q is false. So false and false is simply false. So basically it's a contradiction, and I don't know why they keep writing it as fallacy. So fine. So if they take it as contradiction, we'll say statement 1 is right. Now statement 2 is P implies Q if and only if not Q implies not P is a tautology. So here we'll use truth table method. So this is P, Q, not P, not Q. P implies Q, not Q implies not P, and then P implies Q if and only if not Q implies not P. So here will be true, 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 false, false, true, and false, false. Not P is false, false, true, true, and not Q is false, true, false, true. Now P implies Q, true. Now true, false is false, and all the cases it is true. Now not Q implies not P. So false, it is true. True, false, it is false. False, true, true, true is true. Now P implies Q if and only if not Q implies not P. True, 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 false, false, true, true, true is true, and true, true is true. So that means it is a tautology. So statement 2 is also correct. So statement 1 is right and statement 2 is right. And statement 2 is not a correct explanation of statement 1. So that is option number B. Now the question says this Boolean expression is equivalent to which of the following? So we are given that Pn not Q or Q or not P and Q. So first we'll simplify this one. So we can write it as P or Qn not Q or Q or not P and Q. So we have used distributive law. Now not Q or Q is simply true and A and true is simply A. So this is P or Q or not P and Q. Now we know that disjunction is associative and commutative. So I can write it as Q or P or not P and Q. So I can write it as Q or, and this is P or not P and P or Q. Now P or not P is true and A and true is simply A. So this is Q or P or Q. So now which is P or Q or Q, and Q or Q is simply Q. So this is equivalent to P or Q. So that's your option number A. Now the next question is, we are given 3 statements and the statements are P, Q and R. P says 5 is a prime number, which is true. Now Q says 7 is a factor of 192. Now we look at 192 and if we divide by 7, then it will be 14 and then 52. So this statement is false. And statement R is LCM of 5 and 7 is 35, which again is true. So validity of statements P, Q and R is they are true, false and true. Now we need to find the truth value of which one of these following statements is true. Now the first one is P intersection Q or not R. Now we know that P is true and Q is false, or not R. Not R is false. So true and false is false and false or false is simply false. So that means this statement A is not true. Now what about statement B? Statement B says P or not Q and R. Now P is true, not Q is true and R is also true. So true and true is true and true or true is also true. So that means statement B is correct. Now we look at this statement C. Now what's not P? Not P is false, or this is false and true. False and true is false. False or false is simply false. So the statement C is incorrect and D is not P. Not P is false. Now false and anything is simply false. So the only statement among A, B, C, D which is true is this statement B, which is P or not Q and R. Now question number 20 says, we need to find contrapositive of this statement. And the statement is, if two numbers are not equal, then their squares are not equal. So that means we are given A implies B. We need to find not B implies not A. What is not B? Not B is, if the squares of two numbers are equal, then two numbers are equal. So, which is your option number B. So this expression which is not of not P or Q is logically equivalent to what? So this is not of, now this is not of not P or Q. So it is not of P or Q, which is not P and not Q. And that's your option number D. Now another question is, find the logical equivalent of P and Q or P or not Q and not P and not Q. So we know that disjunction is associative and commutative, so I can write it as P and Q or not Q or P and not P and not Q. Now we'll use distributive property, so I'll write P or not Q and Q or not Q, and then or P and not P and not Q. Now we know that Q or not Q is simply true and A and true is simply A, so I can write it as P or not Q or P and not P and not Q. Now P or P is simply P, so I can write it as P or not Q and not P and not Q. So again conjunction is associative, so I can write P or not Q and not P and not Q. So I'll use distributive property again. So this is P and not P or not Q and not P and not Q. Now P and not P, it is false, and false or A is simply A. So this is not Q and not P and not Q. Now not Q and not Q is simply not Q. So this is not Q and not P. So the statement is equivalent to not P and not Q. Which of the following is a tautology? So we'll start with option number A, and it is P and P implies Q implies Q. So A implies B is not A or B. So I'll write P and this is not P or Q implies Q. So here I'll use distributive law. So I'll write P and not P or P and Q implies Q. Now what is P and not P? P and not P is false, and false or P is simply P. So I can write it as P and Q implies Q. Now again I can write not P and Q or Q. So this is not P or not Q or Q. So I can write not P, and disjunction is associative. So I can write or not Q or Q, and not Q or Q is simply true. So this is not P or true, and if it is not P or true, then it is simply true. So that means option number A itself is a tautology. Now another question is, we need to find negation of this statement, which is if I become a teacher, then I'll open a school. So we need to find negation of this conditional statement A implies B. So we know that A implies B is equivalent to not A or B. So which is equivalent to not of not A and then and not B. So it is simply A and not B. So what is A? A is I will become a teacher, and then we have this conjunction. So that means we'll have this and not B. Not B is I will not open a school. So negation of this conditional statement will be I will become a teacher and I will not open a school. So I will become a teacher and I will not open a school. That's your option number D. Now for this question, we are given a statement which is if it rains, then the match will be cancelled For this statement, we need to find its converse, inverse, contrapositive and negation. So first we'll start with converse of this statement. So we know that this statement is if A then B, then converse of A implies B is simply B implies A. So if I have to write converse of this statement, then the converse will be if match is cancelled, then it will rain. Now, if we have to write inverse of this statement, so we know that inverse of A implies B is not A implies not B. So inverse of this statement simply will be if it doesn't rain, then not B, which is the match will not be cancelled. Now third one is contrapositive. So we know that contrapositive of A implies B is not B implies not A. So if I have to write contrapositive for this statement, then it will be if the match is not cancelled, then it will not rain. So finally this fourth one, that is negation of the statement. So we need to write negation of this conditional statement. So negation of A implies B. So we know that A implies B. So we know that A implies B is equivalent to not A or B. So I can write it as not of not A and not B. So which is equivalent to A and not B. So that means negation of this implication is simply A and not B. So what's A? A is if it rains. So it will rain. And then we have this conjunction and the match will not be cancelled. That is the negation of this conditional statement. Now question number 43. Again it's a biconditional statement. Now it says not of P if and only if not Q is equivalent to P if and only if Q. And second statement is this first expression is a tautology. So again I'll write P Q not Q and then P biconditional Q, P biconditional not Q and negation of P biconditional not Q. So this is true, 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 false, false, true and false, false. Not Q will be false, true, false and true. Now P biconditional Q, so it will be true when both of them they are true or both of them they are false. In all other cases it will be simply false. Now what about P biconditional not Q? P biconditional not Q, true, false, false, true, 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 false, false, true, false, true, false. And if I take negation of that, I'll get true, false, false and true. So this statement, it is not a tautology. So that means statement 2 is incorrect. And the first statement is this expression is equivalent to P if and only if Q. So their truth values are same. So that means statement 1 is correct. So option is statement 1 is true and statement 2 is false, which is your option number B.